Hi everyone, this is GKCS. Today we are talking about Google Zanzibar. This is a system which was written in 2012 at Google, but the paper is from 2019 after a lot of optimizations and challenges that Zanzibar has solved. What does it do? It's an authorization system. You might have seen this when sharing documents at Google. So whether it's Google Drive or Google Docs, when you say share by link, there is what access do they have? Is it viewer access or editor access? So editors can change the file while viewers can just view the file. And there is one hidden permission in Zanzibar, which is the owner. Owners can both edit and view the document, and they can also delete the document if they want. So they have the maximum permission. Okay, so you see that in this stack, as you go up, your permissions reduce. The benefit of this is if you say that a person is the owner of document 1, then you know that they have edit and view permissions also. Now, why is this a big deal? What's the problem? All you have to do is take a table where there are users and documents and store that somewhere, and whenever a person is asking for permission, you just check on the table, right? Well, for Google, they have to store trillions of records. These are the access control lists that they have to store. So for a document, Gaurav has view access. For the same document, Pramod Verma has edit access. And for the same document, Narendra Modi has owner access. So what happens then is you have lots of records that you have to store. And when you need to fetch those permissions, whenever you're trying to authorize a person, then you have to fetch amongst trillions of records. This is in terabytes of data. The second thing is you have millions of queries, authorization queries per second. The only paper which comes close to this in terms of scale that we have looked into is Facebook Tau, right? It also had millions of graph queries per second. You see that there is a hint of a graph here also. A person is the owner of document 1, a person has edit access to document 2. And similar to Tau, the scale is just massive. The third thing to point out how big this problem is the number of distinct nodes you have on this graph. You have billions of people using Google around the planet. So there are billions of users. And trillions of documents. Not every document is created by a user. Some documents are auto-generated also. Some documents are created using scripts. So you have a huge number of objects, edges, and queries in this system. And despite all this, you want tremendous performance. Whenever you're trying to get a document from Google, you want to get that response in a sub-second, so maybe 500 milliseconds. 500 milliseconds is the total time you can give to fetch the document. How much time do you think you can give authorization? Tens of milliseconds, right? So you want the latency of these millions of queries per second to be in tens of milliseconds. This is the first big challenge that we'll face. The other big challenge is how reliable does this system need to be? If authorization fails, Google is down. All documents are inaccessible. So if Zanzibar goes down, Google is out. How often do you think this can happen? Google said that we can have around 10 minutes of downtime per year, which turns out to be something like 99.999% availability. Okay, 5 nines of availability. And one clue that you have in terms of how is this system going to be accessed is you have 99 or greater than 99% of your queries are read queries. Most likely you're going to be setting the permissions of a document when you create it. You at least have 99 read access of that document, of that authorization access control list before a change is made to the document. Now let's go back to 2012. You're the principal engineer at Google and you notice that many of your products, Google Drive, Google Photos, they have documents which can be accessed by different users in different ways. So Gaurav may be part of the engineering team, and at the same time Pramod Verma may be part of the engineering team, right? You can share a document, maybe UPI technical document, with all people who are part of the engineering team. So the way you represent this instead of this graph is through a single line relation. So it's going to be the UPI document is having a relation of edit with everybody in the engineering group. And since you might run out of these IDs, you can also give a namespace. So in this way, using text, using a single line, you can define a relation. This relation defines this edge. Okay. If you want to define this edge, Gaurav belongs to the group engineering, then all you have to do is just say org engineering has a relation of member with Gaurav. Right? You see, everything after the at is the source. Everything before the hash, the starting part, is the destination. So Gaurav has a relation with engineering, and the type of edge is member. In this way, you can represent the entire graph, which describes the authorization permissions at Google. Now, if a person asks for who has access to this document, right, who can edit this document, first what they have to do is they have to find all incoming edges to this document. If it's an individual who's pointing to it, then they get that respective permission. If it's a group, then that group has to be expanded. But in this way, you can authorize any kind of request. If Gaurav asks for a view access to a document, you check whether UPI Tech is having a view access to Gaurav in any way possible. So you spread out as a tree and try to find Gaurav in any one of the nodes. Now this is the overall architecture of Google Zanzibar. You'll see that clients are connecting to this system using requests, and clients, you must have seen the previous videos, we are talking about software clients here. So some piece of code that Google Drive, Google Photos, the engineers there can use to call an API in your system. Now, when they're sending requests through your APIs, there are two major APIs that we should look into. One is a read API and the other is a write API. These requests come and hit the Zanzibar system. Internally, the system has many servers which are storing access control lists. Not all of the access control lists can be stored. Petabytes worth of memory is difficult to store in memory. So what you're going to do instead is have the most recent, most frequently used access control lists in memory, while the rest are kept in durable storage. So this is like a in-memory cache. In fact, the algorithm that is used is consistent hashing by Zanzibar. The servers expose APIs for efficient read and write operations. What are these APIs like? Let's look at the read operation first. You have a source, a relation, a destination, and a timestamp that's possible to pass in the read API. You see there are stars around source, relation, and destination, which means that they're optional. So if you pass all of them, then you're going to get whether this relation exists or not in Zanzibar. For example, does a user have edit access to a document? If Zanzibar finds this relation, it will say true, otherwise false. If you don't pass the relationship type, then you'll get all the relations between these two nodes. So get me all the relations between user A to document D. Zanzibar will check all the groups that user A belongs to, figure out the relations in between, and return all of the tuples for this source and destination. If you just pass the source, you'll get all the relations that this object has with every other destination. So who have access to this document can easily be found using this API. You can also just pass in the destination, all the documents that a person has access to or a group has access to. You see that most of the access patterns are taken care of just using this read API. 99.9% of Zanzibar requests are read, and they basically use a variation of this API. You also have write operations, which are extremely simple. Just pass in the source, the relation, and the destination. So you're adding access of edit to user A for document D is a single API call. Now, one thing you might have noticed about the read and write APIs is they have something called a timestamp, which is what allows data consistency in Zanzibar. The guarantee that Zanzibar gives is if you have a write operation,
let's say of timestamp 100, and a subsequent read operation of timestamp greater than 100, then the write operation will reflect in that read. If instead you have a read operation which is less than 100, then there is no guarantee that the write operation will reflect in that read. Now this timestamp is provided by Spanner. It is literally a timestamp, a globally ordered timestamp.
Okay, that ensures causal consistency. This is managed largely by the client. Now, when these requests, read and write requests, hit the Zanzibar system, the red box here, then internally it can manipulate its state and persist it in a data store. The data store for Zanzibar is Spanner. You might have heard of Google Spanner. It's a highly consistent, highly available system. It's partly the reason why Zanzibar itself is highly consistent and highly available. And what are you persisting? Well, one of the things you're persisting is for every different namespace, for Google Docs, for Google Photos, you keep configurations in Spanner. For Google, this is a very common use case. Whenever you are having any kind of configurations to store for an app, like one document can have at most 5,000 editors. Maybe that is a config that you want to store somewhere. It's a rule. That rule can be stored in Spanner. It's really good for storing this kind of information. The other thing, the other rules that you want to store are relations. So Gaurav has access to a document in view state. Someone else has access to that same document in edit state. Those tuples are going to be stored in Spanner. And finally, you also store append logs in a change log here. So this you can think of as all the operations that you're sending to Spanner, create, update, delete, are all stored in the change log. If there is any state change, any write operation being done, then you want to store it here. Eventually, if one of these databases crashes, it can go and pick up from the changelog all the changes, spin up a new instance, hydrate it with data, and your entire system is fine. You see that Zanzibar is backed by Spanner. Internally, though, Zanzibar is very similar to an in-memory cache. So you can imagine that the cache is sharded. The data in the cache is sharded. And what is the shard key? Whenever you're thinking of a shard key, a good shard key, think about how is the data in this system going to be accessed. Read operations are much more likely than write operations. Order of magnitude 2. So they are 100x more likely than writes. All you need to worry about is object and relation. Okay, user is optional, so we are not taking it into consideration, and timestamp also is not something we are looking into. If you can shard according to these two, if you can club them together and hash these two parameters, then you'll get a number. That number can be used to route the request to one of these ACL servers. Okay, so the shard key is the object ID and relation. But in most cases, the relation object, whether it's viewer, editor, or owner, is not varied. There's just 3 of them. So you want to keep them all also together. You don't want to keep all viewers of this object somewhere and all editors of this object somewhere else in a different shard. So in fact, you can make this even more efficient and just say the access pattern says get me all relations for an object. So the shard key is just the object ID. Now I can easily query for get me all the people who have view access on this document. The document is the shard ID. I'll find that shard and then I'll find all the relations from that shard which are either viewer or editor or owner, and then I'll get all those users. That takes care of the core part of Zanzibar. Clients can make requests and those requests are being persisted. What also happens in the background is this change log not just is useful for backups, but is also useful for watching for events. So for example, you want to add users to a document as they join a group. All people who are in the group Mumbai should get notifications for fire alarms in Mumbai. So the watch service can actually have events being streamed from the changelog to watchers, clients who are interested in those type of events. So you can subscribe to an event as long as you mention the object ID, all relevant changes for that will be pushed to you by the watcher service. And this is not in the critical path. It's not in the main hot path. It's here pulling from the changelog. So it's eventually consistent, but it's quite good. Similarly, you have this data being piped to a background job, which creates snapshots. So you no longer have to hydrate data using a changelog from the start of Google 2012. You can do it from 2024 September. So you take this snapshot and you take all the changes after 2024 September, and that is much faster than taking it from 2012. Finally, these snapshots are then used for indexing. What is indexing in Zanzibar? Well, there are certain tuples, certain relations which are very complex. So there is a document which is shared with a particular group, and it is not going to be shared with another group. So share this document with everyone in Mumbai, but don't share it with people who have less than 10 years of experience. That is complex. There is a group and there is an exclusion of a group. These are set operations. You can do them in memory. The only thing is it takes time. And since you want to answer requests in less than 10 milliseconds, you want to pre-compute the groups, pre-compute the user sets as much as you can using a system called Leopard. Now this uses snapshots to pre-compute frequently accessed groups and sends those computations or user sets to Zanzibar. It also partly uses the watcher service so that it gets real-time updates. This is a background job which runs periodically like a cron, and this is real-time. So that's how requests flow in Google Zanzibar. In many ways, it's like a multi-level cache. 12% of the requests are saved here, 99% of the requests are served here, and just 1% of the remaining requests are taken care of over here. This is what helps them reduce the overall latency of the system. Thank you for watching this video. Google Zanzibar is a really involved system. It's got various optimizations, two of which I have linked in the description. I have written blogs on request collapsing and request hedging. If you want to check them out, there's links in the description. Until next time, then see you. Bye-bye.
I wonder why you're sticking around. But if you are, then may I suggest a series of system design videos that will be released over the next 6 weeks. Do check it out. I have it pinned in the top comment. Have a great day.